Now this is x-axis, my dear students, this is x-axis. Now this is y-axis. Now this one is z-axis. Now here we are writing here only positive, the stresses acting on the positive faces only. Now this is sigma x plus. Now this one is tau x y plus. Now this one is tau y z plus. This is tau y z plus. Again this direction stress is a sigma y plus, because it is a positive y phase, it is a positive z phase, it is a positive x phase. Now this direction stress is tau y x plus. Now this direction tau y z plus. Now this is a sigma z plus, sigma z plus. This one is tau z x plus. Now this one is, what is this one? Tau z y plus. Now when a body is in equilibrium condition, algebraic sum of forces is equals to 0. That is, algebraic sum of forces x direction is equal to 0, algebraic sum of forces y direction is equal to 0. Now I am consider sigma fx is equals to 0. At that time when a body is in equilibrium condition, first we have to identify the equilibrium equation by using sigma fx is equal to 0. Now here this is sigma x plus. Now for this width of the elemental volume is dx. So for this length of the elemental volume is dy. So here is the height of the elemental volume is dz. Now coming to here, what is the force on this face, on that is x-axis direction? What are the forces acting x-axis direction? We know the stresses acting on x-axis direction. This one is stress acting x-axis direction, this one stress acting x-axis direction, this one stress acting x-axis direction. From this we are finding the forces. That is nothing but algebraic sum of forces on positive phase and negative phase is equals to 0. Now it is acting this positive y phase, positive x phase, that is sigma x plus, this is a stress. It is acting on the phase dy and dz. So force in x direction is sigma x plus dy dz minus of. There is a force is acting on negative phase, that is stress on negative phase is sigma x. So force is equal to stress into area. This is first term. Again plus, again there is another force is acting in x direction, my dear students. So here is, we know the stress. From this stress we are able to estimate the force, that is tau y x plus. Tau y x plus, y x plus, it is acting x and dx and dz surface, that is dx and dz minus of. On this negative phase it is acting tau y x dx dz. Okay. Now similarly for this, so here is yz plus, so that is equals to tau zx plus, tau zx plus, this one tau zx plus, it is acting on which surface? Dx dy surface, dx dy minus of tau zx, that is negative phase, tau zx, force acting negative phase, tau zx into surface area dx dy plus body force. So body force acting in x direction is fx per unit volume. For dv volume it can be called as a fx into dx into dy into dz, that is equals to 0, my dear students. Now we are solving this term first of all, that is sigma x plus is nothing but sigma x plus dou by dou x of sigma x into dx. This is already derived in tables. So into dy dz minus of sigma x dy dz. Okay, plus again similarly here tau y x plus, that is tau yx plus dou by here is a, it is in, so dou y of, you remember, all of you remember my dear students, dou y of tau yx into dy into here is into dx dz. Okay, so minus of here is tau yx dx dz plus similarly here is, so tau zx plus this one tau zx plus, that is tau zx plus dou by dou z of tau zx into dz minus of here is, what is this next one, tau zx dx dy plus f of fx dx dy dz, that is equals to 0. Here is after simplification, so multiply dy dz for this term and this term. So this term and this term cancel out. I will write here, that is sigma x dy dz plus dou by dou x of sigma x dx dy dz minus of sigma x dy dz plus here multiply this one tau yx into dx dz plus dou by dou y of tau yx dx dy dz minus of tau yx dx into dz plus similar fashion for this also tau zx, here is this term is missed here, that is dx into dx dy, there is a term missing here, that is multiply this with this term tau zx dx dy plus dou by dou z of tau zx into dx dy dz minus of this term, remaining term, minus tau zx dx dy plus f of fx dx dy dz, that is equals to 0. So I will use different color for our clarity purpose. Here is this term and this term cancel out, here also this term and this term cancel out, here also this term and this term cancel out. So and also divide this equation both side, that is left hand side and right hand side, with dx dy dz. Now I will write in next phase. Dou by dou x of sigma x dx dy dz plus, what is the remaining term, next term here? So the remaining next term is dou by dou y of tau yx, dou by dou y of dou by dou y of tau yx dx dy dz plus, what is the next term here? What is the next term here? Next term, remaining term is dou by dou z of tau zx, dou by dou z of dou by dou z of tau zx into dx dy dz plus fx into dx dy dz, that is equals to 0. So divide the entire equation both left hand side and right hand side by using dx dy dz. So here is this one cancel out, here is, and this one cancel out here, and this one cancel out here. So the terms left here, dou by dou x of sigma x plus dou by dou y of tau yx plus dou by dou z of tau zx plus fx is equals to 0. This is equilibrium equation in x direction, my dear students. So similarly, so by seeing this figure also, we are able to write the equilibrium equation in y direction. What are the forces acting in y direction, my dear students? Now this is y direction. So here is one force, you see here is a one force. That is one force. There is another force is here. This is a y direction. So this is also y direction. So similarly, by seeing this, we are able to write the equilibrium equation in x direction. This is, all of you see, my dear student, this is sigma z plus. This is equals to sigma x plus. This is equals to tau yz plus. This is equals to sigma y plus. So these equations are like this only. Now here, so what is this equation here? Dou by dou y of sigma y direction, dou by dou y of sigma y plus, again there is another one is there, that is dou by dou z of tau yz plus, again there is another term y direction, dou by dou x of tau xy plus fy is equals to 0. Similarly, what are the forces in z direction, my dear students? So this is one force in z direction. There is, I will use different color for your clarity purpose, my dear students. Here so forces in z direction, this is z direction, this is y direction, this is x direction, my dear students. It is x direction, it is y direction, it is z direction. Forces in z direction, this one, again there is another one, this one, again there is another one, this one. These are the three forces in x direction. Now this equilibrium equation can be written as, what is this? First of all, this one, dou by dou z of sigma z plus, again dou by dou x of tau xz plus dou by, again here dou by dou y of tau yz plus fz is equals to 0. So there are, here is sigma fy is equal to 0, you will get this equation. Sigma fz is equals to 0, you will get this equation, my dear student. These three equations are equilibrium equations. Okay, my dear students, all of it clear? So it's a very simple, by writing this only we are very simple. See, for example, I am consider x direction. See, so here is, I will use different color. X direction, this is x direction, one force, that is this one, that is dou by dou x of sigma x over. Next, what is x direction force? There is another force, this one, dou by dou y of this one, yx. So see here, my dear students, here is shear stresses are complementary nature, that is yx is equal to tau yx is equal to tau xy, tau zx is equal to tau xz, like this, complementary nature. So here is tau yx, this one. So one force is this force is x direction, this one, this force is x direction, this one, there is another force x direction, that is this one, that is dou by dou z of tau zx. So plus fx is equals to 0. So these three are equilibrium equations, my dear students. Thank you.